this video is going to help you identify strong and weak acids. The first thing that we're going to do is strong acids. What you'll notice is that the forward reaction predominates, which means that there's a big line here and just a little line coming back. This suggests that the arrow pointing forward is that you're going to have more products and much less reactants. A nice example of this is hydrochloric acid plus water. The H from HCl gets bumped over to the water, making H3O+, and it leaves behind Cl-. Remember, you have more of this, okay? So when calculating pH, remember acid is H+, or another code word for H+ is H3O+. So this right here indicates to me acid. The HCl itself is an acid, but really what makes it an acid is, does it ionize? Okay, so we call this a strong acid because we have more H3O+, or you can call it H+. If you look at this, you'll notice because we have more H3O+ and Cl-, my ionization is complete. So when you have charge, you have ions. So because the arrow is pushing way forward and you have much more of this stuff, the ionization is said to be complete. This actually correlates to your conductivity. In order to move around electrons, which is what you're doing with conductivity, you need to have charge. Electrons are negative. So the only thing that moves those around is charge. So you've got to have a lot of charge to move that around in order to have good conductivity. So complete ionization gives you good conductivity. If you look at the conjugates, remember HCl, we can pair up. Conjugates only differ by one hydrogen. And if you'll notice, this is the acid because it has one more hydrogen, and this is the base. We're going to call this a conjugate base because it's in the product. If you'll notice the arrow, this is our weak because it's on this side, and this is our strong. Weak acids are where the reverse reaction predominates. So small on top, big on the bottom. One of our best examples is acetic acid. When acetic acid is put into water, the H on the acetic acid gets kicked to the water, again producing hydronium, which is what we call acid, plus CH3COO-. If you look at the ionization, because the arrow pointing forward is little, we have less of this. As a result, our ionization is partial. We don't have that many ions. That correlates also, if you don't have that many ions, you can't push around electrons, so your conductivity is poor. If I have my acetic acid and I connect it to its conjugate, they only differ by a hydrogen. This would be the acid because it has more hydrogen, and this would be the base. And I'm going to call it a conjugate base since it's on the product side. Because this arrow is much longer, I'm going to call this a strong conjugate base. And over here, which makes the short arrow, would be the weak acid. Okay? I do want you to know that vinegar is a weak acid. This is something that we use for neutralization, something we'll work with in a little bit. Let's look at some of our examples. First of all, the first one is acetic acid, has a poor conductivity. So once again, we have less of the ions, so the conductivity would be poor. I've got to have ions to have conductivity. HCl has a weak conjugate. If you'll notice, we did that before. HCl, if my acid is strong, my conjugate's got to be weak. Hope that helps. Look for the video on bases.